Section 230.71 of the National Electrical Code 2023 edition requires that the service disconnecting means such as the meter base be installed at a readily accessible location. This location must be either outside of a building or within a building within 6 feet of the point of attachment of the service conductors to the building. Section 230.71 C allows the service disconnecting means to be located outside of a building if there are 2 or more buildings or structures on the same property. However, this provision does not apply if the meter base is being installed on a garage that is attached to the house. Section 230.70 states that the service entrance conductors shall be grouped together and protected by an enclosure or raceway. Section 310.15 B1 requires that electrical raceways shall be securely supported. Based on the provided information, a plan meets the code requirements for service entrance and disconnect requirements if the following conditions are met. Firstly, the service conductors from the meter base to both panel boards are grouped together in the same raceway, such as a 3-inch polyvinyl chloride conduit. Secondly, the raceway is securely supported along its entire length. Thirdly, the panel board in the basement is connected to the raceway at the point where it enters the basement. The National Electrical Code does not require a separate disconnect for each panel board connected to service conductors. The grouping of disconnects refers to the requirement that the service entrance conductors be disconnected at a single location. In your case, the meter base serves as the single point of disconnect for both panel boards. Therefore, no separate disconnect is required at the second panel board in the basement if the meter base provides the main disconnect. Ensure that all wiring and installations comply with local electrical codes and regulations, and consider consulting with a qualified electrician for guidance and inspection to ensure safety and compliance. The term service conductors refers to the conductors that run from the utility company's service point to the service disconnecting means, typically the main breaker in the electrical panel. These conductors carry the entire electrical load for the building. The service disconnecting means is the main switch or breaker that allows you to disconnect all power to the building. This is typically located at the meter base or in the main electrical panel. A panel board is a distribution point for electrical circuits, typically containing circuit breakers or fuses to protect individual circuits. It is also known as an electrical panel or breaker box. A raceway is a channel designed and used expressly for holding wires, cables, or busbars. Raceways can be made of metal or non-metallic materials such as polyvinyl chloride conduit. When installing electrical raceways, it is important to use appropriate fittings such as couplings, connectors, and elbows to ensure a secure and watertight connection. The type of fitting depends on the type of raceway and the application. When running conduit along a wall, use appropriate supports such as conduit clamps or straps to securely fasten the conduit to the wall. The spacing between supports should comply with the National Electrical Code and the manufacturer's instructions. When bending conduit, use a conduit bender to avoid kinking or damaging the conduit. The bending radius should comply with the National Electrical Code to ensure that the conductors can be easily pulled through the conduit. When pulling conductors through a raceway, use a pulling lubricant to reduce friction and prevent damage to the conductors. Ensure that the conductors are properly sized for the load they will carry and that they are color-coded according to the National Electrical Code. When connecting conductors to terminals, use appropriate connectors such as wire nuts or crimp connectors to ensure secure and reliable connection. Torque the connectors to the manufacturer's specifications to prevent loose connections. When installing electrical equipment, such as panel boards and disconnects, ensure that they are properly grounded according to the National Electrical Code. Grounding provides a path for fault current to return to the source, which helps to protect against electric shock. When working with electricity, always follow safe work practices, such as wearing appropriate personal protective equipment, de-energizing circuits before working on them, and using insulated tools. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Firstly, conductors must be protected from physical damage. Secondly, conductors must be insulated. Thirdly, conductors must be properly sized for the load. Fourthly, conductors must be properly terminated. Fifthly, conductors must be protected from overcurrent. Sixthly, conductors must be grounded. It's essential to size conductors correctly based on the ampacity requirements of the loads they will serve, while also considering voltage drop and other factors. For example, a 20 amp circuit typically requires 12 American wire gauge copper conductors, while a 30 amp circuit typically requires 10 American wire gauge copper conductors. Always consult the National Electrical Code and local codes for specific requirements. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overheating due to excessive current flow. These devices should be sized appropriately for the ampacity of the conductors they protect. For example, a 15 amp circuit breaker should be used to protect 14 American wire gauge copper conductors, while a 20 amp circuit breaker should be used to protect 12 American wire gauge copper conductors. The National Electrical Code provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the methods of connecting grounding electrodes, and the bonding of non-current carrying metal parts. Grounding helps to protect against electric shock and minimizes the risk of fire. The National Electrical Code specifies minimum clearances for electrical equipment, such as panel boards and disconnects, to ensure safe access for maintenance and repairs. These clearances vary depending on the voltage and type of equipment. Always consult the National Electrical Code for specific requirements. Electrical equipment should be installed in a dry location to prevent corrosion and electrical hazards. If equipment must be installed in a damp or wet location, use equipment that is specifically designed for those conditions, such as waterproof or rain-tight enclosures. The National Electrical Code requires that all electrical work be performed in a neat and workmanlike manner. This means that conductors should be properly supported, terminated, and labeled, and that equipment should be installed according to the manufacturer's instructions. Neat and workmanlike installations are safer and easier to maintain. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. Always consult the latest edition of the National Electrical Code for specific requirements. Local electrical codes may be more stringent than the National Electrical Code. Always comply with local codes and regulations. It is always a good idea to consult with a qualified electrician for guidance and inspection. An electrician can help you ensure that your electrical installation is safe and compliant with all applicable codes and regulations. Firstly, ensure the meter base is rated for 400 amps and is suitable for outdoor use, complying with local utility requirements. Secondly, use 3-inch polyvinyl chloride Schedule 40 or Schedule 80 conduit for underground runs, ensuring it's buried at the correct depth per local codes, typically 18 to 24 inches. Thirdly, use appropriately sized conductors for the 200 amp panels. For copper, consider 3/0 American wire gauge, but always calculate based on load and voltage drop. Aluminum conductors may also be used, but require larger sizes. Fourthly, use separate grounding electrode conductors from each panel to a grounding electrode system, ground rods, or other approved electrodes, ensuring proper grounding per National Electrical Code 250. Fifthly, ensure all connections are properly torqued per manufacturer's specifications to prevent loose connections and potential overheating. Sixthly, label all circuits clearly in each panel for easy identification and maintenance. Seventhly, use correctly sized breakers for each circuit to protect against overloads and short circuits. Eighthly, ensure the 200 amp panels are rated for the available fault current at the service entrance. Ninthly, use appropriate conduit fittings and seals to prevent moisture from entering the raceways, especially in underground installations. Tenthly, consider using a surge protective device at the main panel to protect against voltage surges. The meter base typically serves as the point where the utility company's service conductors connect to your building's electrical system. It houses the electric meter, which measures the amount of electricity you use. The meter base must be properly sized to handle the load of your electrical system. The service entrance conductors are the conductors that run from the meter base to the main electrical panel. These conductors carry the entire electrical load for your building. The size of the service entrance conductors must be adequate to handle the load of your electrical system. The main electrical panel is the distribution point for all of the electrical circuits in your building. It contains circuit breakers of fuses that protect individual circuits from overloads and short circuits. The main electrical panel must be properly sized to accommodate all of the circuits in your building. Branch circuits are the individual circuits that run from the main electrical panel to various outlets, lights, and appliances throughout your building. Branch circuits must be properly sized to handle the load of the devices they serve. Grounding is an essential safety feature of electrical systems. It provides a path for fault current to return to the source, which helps to protect against electric shock. All electrical equipment must be properly grounded. Bonding is the process of connecting all non-current carrying metal parts of an electrical system together to create a common ground. Bonding helps to prevent voltage differences between metal parts, which can cause electric shock. All metal parts of an electrical system must be properly bonded. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices must be properly sized to protect the circuits they serve. Short circuits occur when there is a low resistance path between two conductors in an electrical circuit. Short circuits can cause a large amount of current to flow, which can damage electrical equipment and cause fires. Ground fault circuit interrupters are designed to protect against electric shock. They detect small amounts of current leakage to ground and interrupt the circuit before a person can be injured. Ground fault circuit interrupters are required in certain locations, such as bathrooms and kitchens. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults. They detect arcing faults and interrupt the circuit before a fire can start. Arc fault circuit interrupters are required in certain locations, such as bedrooms. Surge protection devices are designed to protect against voltage surges, which can damage electrical equipment. Surge protection devices should be installed at the main electrical panel and at individual sensitive electronic devices. Electrical inspections are performed by qualified electrical inspectors to ensure that electrical installations comply with applicable codes and regulations. Electrical inspections are required for new construction and for certain types of electrical work. Firstly, use appropriately sized conduit fittings and connectors that are rated for the type of conduit being used. Secondly, ensure that all conduit joints are properly tightened to prevent water from entering the conduit. Thirdly, seal the ends of the conduit with duct seal or other approved sealant to prevent moisture from entering the conduit. Fourthly, use waterproof or rain-tight enclosures for electrical equipment that is installed outdoors. Fifthly, install weep holes in conduit runs to allow water to drain out. Sixthly, protect underground conduit runs from physical damage by burying them at the proper depth. Seventhly, use corrosion-resistant materials for conduit and fittings that are installed in corrosive environments. Eighthly, consider using heat shrink tubing or other protective coverings to protect conductors from moisture and corrosion. Ninthly, inspect conduit runs regularly for signs of damage or corrosion. Tenthly, repair any damage to conduit runs promptly to prevent water from entering the conduit. Firstly, the American wire gauge size must be adequate for the intended current. Secondly, the insulation must be rated for the voltage and temperature of the application. Thirdly, the conductor must be suitable for the environment in which it will be used. Fourthly, the conductor must be properly terminated to ensure a reliable connection. Fifthly, the conductor must be protected from physical damage. Sixthly, the conductor must be properly supported to prevent sagging or strain. Seventhly, the conductor must be labeled to identify its purpose. Eighthly, the conductor must be properly grounded to prevent electric shock. Ninthly, the conductor must be inspected regularly for signs of damage or deterioration. Tenthly, the conductor must be replaced if it is damaged or deteriorated. The neutral conductor provides a return path for current in an electrical circuit. It is typically grounded at the service entrance to provide a reference point for voltage. The equipment grounding conductor provides a path for fault current to return to the source, which helps to protect against electric shock. It is connected to the metal enclosures of electrical equipment and to ground. The grounding electrode conductor connects the grounding system to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode provides a connection to the earth, which helps to stabilize the voltage and provide a path for fault current. The National Electrical Code specifies the minimum size and type of grounding electrode conductor that must be used for different types of electrical systems. The bonding jumper is a conductor that connects two or more metal parts of an electrical system together to create a common ground. Bonding jumpers are used to ensure that all metal parts of an electrical system are at the same voltage potential, which helps to prevent electric shock. The National Electrical Code specifies the minimum size and type of bonding jumper that must be used for different types of electrical systems. The main bonding jumper is a conductor that connects the neutral conductor to the equipment grounding conductor at the service entrance. The main bonding jumper provides a path for fault current to return to the source, which helps to protect against electric shock. The National Electrical Code specifies the minimum size and type of main bonding jumper that must be used for different types of electrical systems. Firstly, ensure that the wiring is properly sized for the intended load. Secondly, use the correct type of wire for the application. Thirdly, make sure all connections are tight and secure. Fourthly, protect the wiring from physical damage. Fifthly, properly ground all electrical equipment. Sixthly, install ground fault circuit interrupters in wet locations. Seventhly, use arc fault circuit interrupters in bedrooms. Eighthly, install surge protection devices to protect against voltage surges. Ninthly, have the electrical system inspected by a qualified electrician. Tenthly, follow all applicable electrical codes and regulations.